A sudden flash, a silent metal shell breaking apart high above the Earth. Astronauts trained for months felt time slow as systems failed in an instant. Space is unforgiving, and mistakes are amplified by speed, vacuum, and distance. Some disasters were born from tiny oversights that cascaded into catastrophe. Others came from design choices that worked on paper but failed in the harsh reality of orbit. The story of space disasters is also the story of human curiosity and stubborn problem-solving. In the early days, missions pushed limits with incomplete knowledge and urgent ambition. One failure taught engineers that a single valve left open could doom an entire mission. Another taught that materials behave differently when every breath of air is gone. Launch failures exposed how vibrations and acoustics could tear structures apart. Re-entry tragedies revealed the brutal heat and the thin line between protection and destruction. Communication blackouts turned simple delays into life or death uncertainty. Often the same decisions that brought success also hid the seeds of failure. Redundancy became the mantra. Duplicate critical systems in case one fails. But redundancy adds mass, and mass changes everything for rockets fighting gravity. Engineers learn to choose where to save weight and where to accept risk. Sometimes the most advanced systems failed because they were too complex to understand quickly. Other times, simple human error in a moment of fatigue changed history. The Challenger disaster forced an unflinching look at organizational pressure and ignored warnings. Apollo 13 showed how improvisation and calm leadership could save lives against impossible odds. Each crisis left technical lessons, new seals, updated simulations, stricter checks. Safety culture evolved to value dissent and meticulous documentation over rushed optimism. Simulations grew more realistic, exposing subtle interactions once invisible on paper. Modern missions now balance automation with human oversight to catch the unexpected. Yet risks remain: debris, software quirks, and the simple unpredictability of nature. Every failure leaves a scar, but each scar is etched with lessons that make future journeys possible. Engineering is a quiet form of courage that builds bridges to the stars from hard-won knowledge. Disasters will repeat until lessons sink into design, process, and mindset. The cost of exploration is high, but the stories of failure have reshaped the way we reach beyond Earth. Respect for the unknown, disciplined engineering, and humility will guide the next generation of missions. Space will always test us, and our best answer is to learn, adapt, and build safer paths to the stars. The lessons engraved in metal and memory are the true engines of future exploration. We keep looking up because every risk taken has taught us how to protect what matters most: human life and the promise of discovery. In the quiet after a failure, engineers do their work again with steadier hands and sharper minds. Their craft turns tragedy into knowledge and knowledge into the fragile, beautiful skill of getting home.